Hi guys, welcome to my channel Whiz. In this video, we're going to talk about ETL data warehousing. Since 2004, ETL extract, transform, and load data and data warehouse have been frequently, similarly, and correctively searched. This is because ETL and the data warehouse are interrelated terms. The relationship between these terms can be confusing. The ETL pipeline is a process using for integrating data from multiple sources into a central repository, while data warehousing is the process of storing and managing this data in a way that it makes it easy to access and analyze together. ETL and data warehousing are critical components of modern data management, allowing businesses to extract valuable insights from the vast amount of data they collect. The relationship between ETL and the data warehouse is not always well understood. ETL and data warehouse have been regularly searched on the Google since 2004. To clarify the relationship between ETL and data warehouse, in this video we will explain the process of data mapping, data warehouse architecture, ETL and data warehouse best practices, future of ETL and data warehousing. Extracting data for data warehousing. Extracting data, the first step in the ETL process. Data extraction often involves extracting data and pulling data from a variety of data sources such as databases, applications, programming interfaces, and flat files. Some common techniques for data extraction include batch processing, real-time streaming, and chain data capture. It is important to handle data quality issues during the extraction processes, such as ensuring that all the data used is complete and accurate. Additionally, when dealing with large volume of data, it may be necessary to use techniques such as parallel processing and distributed computing to manage the load of data extracted well. Loading data into the data warehouse. The final step in the ETL process is loading data into the data warehouse, which involves moving the transformed data into the central repository. Data can be loaded using the variety of methods, including bulk loading, incremental loading, and tickle loading, compressions, and partitioning techniques as well as optimized database scheme designs are best practices for optimizing performance loads data and minimizing data loads time. Using error logs, data profiling, and data quality dashboards are some strategies for handling errors and data validations during the loading data integration process. So, number 4, designing the data warehouse. Designing a data warehouse requires careful considerations of data modeling and dimensional modeling techniques. The data modeling process involves designing the schema and tables for the target database or data warehouse itself. On the other hand, the dimensional modeling process involves the designing the structure and relationships between the dimensions and fact tables. Strategies for optimizing query performance and data access includes using indexing, partitioning, and materialized viewing. ETL tool and technologies. There are many ETL tools and technologies available in market, both commercial and open source. Some popular open source ETL tools include Informatica, Talend, and Apache Nifi. Choosing the right ETL tool depends on the factors such as organization's budget, data volume, and technical requirements. Different ETL approaches include using code-based ETL frameworks, graphical ETL tools, and cloud-based ETL platform. Data warehousing architecture. There are several different architectures for data warehousing, including traditional cloud-based, hybrid, traditional data warehousing. In traditional data warehousing architecture, the data warehouse is hosted on premises, meaning that the hardware and software required to manage and maintain the data warehouse are located within the data scientist or organization own data center. Cloud-based data warehousing. Cloud-based data warehousing is a modern way to build manage data warehousing using cloud computing technologies. Some popular cloud-based data warehousing solutions includes Amazon Redshift, Google BigQuery, and Microsoft Azure Synapse Analytics. These solutions typically have multiple data sources that offers features such as parallel processing. Hybrid data warehousing. The hybrid data virtualization architecture combines traditional and cloud-based approaches. It utilizes on-premises and cloud infrastructure based on budget, data volume, and technical requirement. The data warehouse enables organizations to reap benefits from both approaches.